Hello and welcome to Don't Stop at the PowerShell Pipeline. Build a CI/CD pipeline for your PowerShell module deployment. So today we're going to be walking through taking a module. Well, there's some prerequisites in play here, assuming you already have a module. We're going to talk a little bit about the module structure, but we're largely going to be using GitHub and GitHub Actions workflows to take that module, get it to Git, get it up to GitHub, and then automatically deploy it to the gallery. If you're here, it's because you want to learn about CI/CD pipelines for PowerShell modules, or you want to see if my laptop survives this session, because yesterday did not go as well. With that, of course, thanks to the sponsors who make Summit possible. Without the sponsors, Summit wouldn't be possible, or at least not as good as it is. Quick about me. Been a PowerShell user for a long time. I love Linux. I don't think that had anything to do with the crash yesterday. I think I have a faulty HDMI port. That was what's causing the flickering and the crash. I think we're good today. I love NeoVim and mechanical keyboards, and I got specs down below. And I have a blog. I don't really update it often. There's some good stuff on there, but don't expect good stuff to come out all the time. So what do we need to do a PowerShell module CI/CD pipeline that takes it from your machine and gets it up to the PowerShell gallery? Of course, using GitHub. This is going to be a little opinionated. I want to stress that there's a million different technologies you can use to do this. You could be using GitLab, Azure DevOps. You probably don't even really need to use Git. You probably could use other things like SVN or TFVC. That's a world that I don't know, but this is going to be using Git and GitHub. So what you're going to need the module. Hopefully you already have some validation steps that you're running locally, like script analyzer, pester. You're going to need a GitHub account. We're not going to create a GitHub account. This assumes you have one. They're free to make. This also assumes you have a PowerShell gallery account. We're not going to make one. This kind of assumes you have one. They're free to make. So, but we will make the repository. We will generate an API key on the gallery. And we're not going to be writing the actions in this session. We're going to walk through what they're going to do. There's a lot of great sessions this year on GitHub Actions and writing that YAML. This is not a course on YAML or a session on YAML, so we'll look at it, but we won't be writing it on the fly. So what is the CI/CD, the continuous integration, continuous delivery for our PowerShell pipeline? I covered this a little bit, but largely what these GitHub Actions are going to do, they're going to run a CI. This is basically going to run our linting and testing, so script analyzer and pester. And for the continuous delivery or the deployment, we're going to rerun that validation. There's some optional things I put in here. This is kind of like, would be a part 2 of this session. We're not going to go into it. I'll talk a little bit about it. So you can optionally do some cleanup and some versioning. We're going to do that manually. And then it's going to deploy to the gallery. Now it's time for the demo. So if you know me, you know I love Markdown. So of course, we're going to start here. This is just for me to keep myself on track, and it's a nice, pretty terminal Markdown file for you to follow along. I talked a little bit about this. So again, this assumes you have a module. We're going to focus on the structure right after this. And of course, you need a GitHub account, which is free, PowerShell Gallery account, which is free. If you have a module that doesn't conform to the structure we're going to be talking about, these concepts still apply, but you're going to need to modify your pester tests and your GitHub Actions that do the deployment. We'll talk a little bit about why that is. And when I say a flat module, I mean you have a PowerShell module that's a PSD one and a PSM one. We're going to talk about the structure right in a minute. So, and somebody let me know if the screen starts flickering, but I think we're good. So what's in play? And I don't want to beat this to death because we talked a little bit about this. Yeah, I think we already talked about these things. Cool. So let's talk about the module structure. Sorry, I'm going to need both hands. All right, why the structure? Again, this is a little opinionated, but I like to structure my modules in a way where the functions are individual PS1 files, even separated by public and private. The PSD one, of course, is still there for your kind of module metadata, and the PSM one is really what facilitates dot sourcing it or doing any kind of other kind of pre-setup you want, maybe doing like the auto completion for certain parameters, type accelerate, I forget what they're called, but you get the gist. Like if you want to set anything up before you actually load the module, the PSM one is really what's going to facilitate that. So we're going to be using a dummy module here. I think it's called PS Summit Demo, and it's going to have a private function that's not exposed. I have a hard-coded dependency, so this is in the manifest. We're going to say this module requires PSTCPIP. There's a function that does use that. If you take nothing else away from this session, I cannot recommend more the PSTCPIP module. It is phenomenal for doing anything kind of web or TLS related. I think there's some content out there for that, but we're not going to dive in depth. We're just going to be using it to get some certificate information. And it's structured in a way that's going to allow the CI/CD, like the GitHub actions that do that, to work better. So we're going to look at the structure, but just before we even do, it's not as easy as just making a folder and stuffing a PSD1 and a PSM1 in it, but Plaster is a great way to boilerplate, scaffold all that, so you don't have to do it every time. Let's just take a look at the module, because it's going to be a little bit more exciting. Let me make this a little bigger. So we will be using NeoVim, but we're just looking at this, so it's no big deal. So effectively, this is the root of the module. So we have PS Summit Demo. That's going to be the module name. And within it, we have .github, .git. We'll worry about those later. But the things I want to really call out are like the SRC, the source directory, and the test, because this is really the kind of crux of the whole module. So like I said, we have a few functions here. They're separated into private and public directories. And then if we take a look, start with the PSD one. We have all the typical stuff, fake things, John Stamos for Baked Beans Incorporated. I don't know, I couldn't think anything when I wrote this. We have our version. Here's where we have the required module for PSTCPIP. In the past, I don't like using this required modules because sometimes it gets really strict about when you run PowerShell get, and I don't know if PS Resource get has the same issues, but PowerShell gets really strict when you have a module declared here for certain things like publishing, stuff like that. So I put this in here because we're going to see how you can work around that. Things I have done in the past, if you don't want to have a hard dependency, you can do what's called, I call it a soft dependency. Again, that's usually something I'd wire up in the PSM one, but nothing too crazy here. We have our functions that are exported. There's just 3 of them, and then just our private data. PSM1 is really, it's going to do that unblock file. I don't actually know if that's still needed to this day, but usually, again, I use Plaster to scaffold these, and that's been in the base template. And then here's where we're going to .source our public and private functions on line, what is this, line 7 and 10. So that's what's going to, when the PSD1 calls this PSM1, that's going to pull those in. That's how it knows. And I'm not going to beat the functions to death, but the private get message, it just picks a random message in a list of SimCity 2000 loading messages that's not exposed to the user. That is called by out summit message, which outputs a PS custom object. I think it says like hello summit, and then the other property is that random SimCity 2000 loading message. Get GitHub TLS info, that's the function that has the dependency on PSTCPIP. And get sum of numbers is really complicated. It takes 2 numbers, 2 ints as parameters, and it adds them together. Not quite as impressive if you were in the Azure function yesterday or Azure functions. We're not going to be outputting any fruit. This module is not as good as that, but it's a very important module in its own right. The way this is structured, though, is in a way so that we're only ever shipping that source directory. And there's some debate out there on whether you want to call it source or call it the module name. I usually like source for 2 reasons. Because if you look at the top, my root already is the module name, and then I just feel like it's awkward to see the name and then the directory right under it, the same name. I'm on NeoVim here, so it's a little bit more bare bones. However, I'm assuming most of y'all are VS Code folks, and if you name it source, you get a nice fancy icon. It's a little green folder with a cog on it. So you also get different icons for like public, private. So not that you should just pick the name of it based off of what icon you get in an IDE, but I also just like source is just 3 letters. But we're going to have to rename that to the function name, because basically what you see in source is what we're shipping. That's what people are going to actually install. So if you don't want to ship it, if you don't want people to do install module and have something in there, don't put it in source, because everything else gets left behind. We don't need it after we ship it. It's garbage. It's only useful for the build. And then tests. I have a couple of real high quality unit tests for 2 of the functions. They're super good, well-written Pester 5 tests. They're not. They're just good enough for the demo. And then I have these module tests. And what the module tests are, it's going to validate the structure. It's going to make sure I don't have syntax errors, even though Script Analyzer will do that. It's going to make sure that if I have functions in the public functions folder, that those are exported. If it's not, the tests will fail. It's going to make sure that there's things like valid author. A lot of these things are things that bit me. So every time I went to go deploy a module in the whole history of me doing PowerShell, every time I ran into a problem that was related to my own human mistake, I put something in the module tests to save me from myself effectively. And we'll go run those now. And before I do, README, that actually is going to be what GitHub will do in the root of your repo. It'll parse that README, so whatever you put in there will show up, look kind of pretty right in the root of your repo. And then we have an MIT license and a git ignore. We're not going to go crazy with the git stuff, but git ignore is nice if you don't want to ship or you don't want to commit into git like your .vs code directory. Oops, sorry. So, oops. Typing's always the hardest part. So I said I had these tests. So I'm in my module directory right now. We can see that. We see like my source and test. If I wanted to see the hidden stuff, I could always just show that. But what the Pester tests look like, and again, this isn't a Pester session, but I can run my tests, those 3 files. Everything is good. You can invoke Script Analyzer. I'm not going to beat that stuff to death, but this is the validation I'd be doing locally while I'm doing my code before I ever even try to push something up to Git or GitHub. So that was the structure. Did we miss anything? Now I kind of talked about what the functions did, the tests. Oh, yeah. So if you do have, like I said, source is what ships. If you want to ship something like a markdown file that's included with the module, or you do have some Pester that's not related to testing the module, but you need that Pester to ship with your code, that's where you just make sure you put it in source. Source is what ships, remember that. And now, we're going to go through the steps. Now, after yesterday when my laptop crashed in the session, and after hearing about all the potential slowness with the conference Wi-Fi, not that I recorded these yesterday, I did it way in advance, but we're going to actually be watching these steps. They're exactly the same steps it'd be like if I was doing it live. I'm not tempting fate, and especially with things where we're going to be clicking around in GitHub, in the gallery, stuff of that nature. So we're going to be watching. I'm going to explain them. Nice thing is I can pause while I go through it as well. But we're going to be going through that. So let's start. So this is my GitHub account. And I guess we could probably do a nice full screen. Make sure I'm not playing. Nope. Cool. So this is my GitHub account. One thing I totally forgot to do when I did record this is I don't have a thing on my mouse that easily shows where it is. So I'm probably going to follow along with my mouse here and just kind of explain it. So where you want to start is you want to go to repositories. So up in the top, we're going to go to repositories, and you're going to click that. Now we're going to create a new repository. Stuff's pretty intuitive. And I would highly suggest giving your repository name the same name as your module. So we're going to name it PS Summit Demo. We're going to give it a nice description. You don't have to do this, but people will see it. I'm going to make this public because this is going to be a publicly accessible code base. If you don't want to do that, you can make it private. If you're using GitHub internally at work, it kind of depends on how your orgs are set up. If you want people in other orgs in your GitHub tenant to be able to see it. We're not going to go crazy with the GitHub stuff. Just know I'm leaving it public. And Because we already have a module, I don't want to initialize this repository with anything. So we're basically going to ignore all these options and then click the green Create Repository. And again, why I'm doing this through the recording, that's a one-time step, and I did not want to attempt doing it live. So once you do, you basically have an empty repository here with a couple steps. You can create a new repository on the command line, that top option, or if you already have it initialized locally as a Git repository, you want to do the second. I'm a creature of habit. I do a lot of my Git stuff through the command line. Technically, we could just copy that whole top block and it would work. When I did this, I actually did the part of the top block in the command line, and then we copied in the bottom block. I don't like my first commit to be first commit in lowercase. When I do my first commit, I like to call it initial commit with a capital I. So what I'm going to do, we're going to copy this bottom line, these three, the git remote add origin with that git branch, and I'm going to go over, and this is in my module directory, which we were just looking at. We're going to initialize it with a git init. There we go. We're going to add everything in this repo, so just do a git add dot. And here's where I like to do my commit, initial commit with a nice capital I. And there we go. So now we have a local Git repository with our first commit in it. Great stuff. So what I did there is that second blob when we created our empty repo that said if you want to associate a local repo that already exists with this GitHub repository, copy these 3 lines. And really what this is doing is it's adding a remote for Git. And again, we're not going to go too deep into all the Git nuances. That could be a whole session in itself. We're going to add one called origin. That's usually the default name that a remote gets. And we're going to use the URL for upstream Git repo. And then we're going to push main up there. So that's all this is doing. Because now, if I go back to GitHub, which I will, and we refresh, we'll see our repo. And now, my local module, as we saw it in the directory right there, is exactly the same as what we're seeing in GitHub. Cool. So what's next? We need to get this to the gallery. So here's where I'm assuming you've already created a PowerShell gallery account. Again, one-time thing. We're not going to go through that. It's pretty easy to do that. But if you go up in the top right corner there and you hit the drop-down with your name, you're going to want to go to API keys. And within there, you're going to want to create a new API key. Now, you have some options here. You can create a key per module. You can create one key to rule them all. You can see here, you can set the expiry. I'm going to just call this key the same name as the module, although you'll see later there's this glob pattern in a minute here. There we go. Before that, you can change the permissions, so I'm just going to leave the default, so push new packages and package versions. I never had to do an unlist, and I've never done like that, the push only new package versions. So I just leave the defaults there. But the select packages with this glob pattern, you could see I have a couple modules already. I wrote one during the pandemic. It's deprecated, it doesn't work, it uses an API that's like long gone. And then I just have a proof of concept one that takes what we're learning today and actually adds a little bit more. It's called PS Swappy. It uses the Star Wars API. Time dependent, we can look at that at the end. But the thing about the glob pattern is you can do star and make it so that this API key works for all of your modules that you want to publish to the gallery, or you can set the keys up so you say, well, this key is only good for these, these modules, but not these other ones. This is up to you. I don't have a lot up there, obviously, but if I was publishing a lot, I'd probably want to use different keys maybe to limit my blast radius in case something happened and a key got compromised. That's a decision you'll have to make. I don't have it's kind of it depends. Once you have the key, I highlighted this. You need to copy this. Where are you going to put this key? Probably in a vault somewhere. Because if you don't put this key somewhere, you can never see it again after this. You can come in here and see that it exists, but you can't actually copy that key. So make sure, and I'm not going to put this in a vault as part of this. And this is the same with, I think, this is definitely the same in Azure DevOps, and I think GitLab as well. Once you make that key, they only let you copy it once. Save it somewhere. So I'm going to hit the copy to copy it. Now, I put it in my vault. We're not going to do that here. What I've done, I'm going to go back to my repository. We're going to go up to the top bar here, settings. And I'm going to go down to the security section for this repository. I'm going to go into my secrets and variables, actions. I'm going to go to repository secrets, hit green button, new repository secret. I'm going to give it a name. I'm going to call it PS Gallery, and I'm going to put it in. Now, I would have pasted the real key in here. I didn't, so you're only seeing the password to my luggage, which I'm going to have to change after this. I was hoping some people would get that one. And you're going to add the secret. Behind the scenes, what you didn't see is I actually put my real key in here, so don't worry, things will work later. But now you have this repository secret. Remember the name, because we're going to need that when we put our actions together. And here we go. We're going to add the GitHub workflows. Before we do, I want to just walk through what they're going to do. So let's take a look. Whoops. I'll explain the directory. Well, I'll explain it right now. We'll see it in the video. Anything specific to GitHub, and I don't remember if Azure DevOps is like this. I don't think it is. I think you can put those pipelines anywhere. But GitHub expects the actions workflows to be in .github workflows, as far as I know. I don't know if you can put them in other places. You can put them in other repositories. You actually, I guess you could technically put them in other places. But we're just going to keep it simple and use workflows. If you want to put something like in the root of the GitHub, there's a place that's where you could put what's called a code owners files. So, for example, I'm the expert on add or get sum of numbers, and I want to make sure that when somebody wants to commit code to that file, I'm always added as a reviewer. That's what you can use with code owners. Again, this isn't a GitHub course. I'm just giving you some free information as we go. But let's take a look. So in my repository, and I'll show you creating this. We're just kind of doing the preview. I just want to show you what these do, because we're just going to copy them in, nothing fancy. We have 3 workflow files. I have my PowerShell module deploy and validate, and then I have a validate workflow. And I don't need to have 3. I'm going to explain why I do. Because if I show you the validate, there's not much here. So again, this isn't a GitHub Actions course, but I'll just kind of explain what this is. We're saying on pull request for the branch, for the main branch, if it's open editor review requested, kick this off. Or if it's a push to branch, we're going to kick this off. Paths ignore is important because what I'm saying here is don't run these GitHub actions if we're changing the GitHub actions or anything in that GitHub folder. We don't want to validate our PowerShell module if we try to change the build. It probably would be pointless to do it. You can do it, but I don't want to, so we're just not going to do that. And then we have our job. Oh, and workflow dispatch, this means you can kick this off whenever you want. If you're just bored on like a Wednesday night, you're like, man, I wish I could validate my code that's sitting in GitHub. You can go do it. That's why I like to add workflow dispatch. It's nice to have. It's good for troubleshooting as well. But in the jobs here, we have our validate module. And you can see this uses that validate workflow YAML. And the reason being is because this is the actual YAML that's doing the validation. So here, we're going to run it on just GitHub stuff, Ubuntu latest. And on workflow call means this workflow is only called by other workflows. So you can't call this one directly. But we can still run it if we want to use the workflow dispatch on the validate. So when the validate runs, we're going to check our code out. And this line here, this next step, ensure module dependencies are present. This is what's going to save you, or at least save some hassle if you have a hard-coded module dependency. That's not going to be on the GitHub Actions runners. So what this is going to do, it's going to parse the PSD1, look for what's in that, and it's going to go install them, which is great because this wouldn't work. PowerShell get would throw an error if we tried to do stuff and the module dependencies weren't present. So that's why I wanted to put a module dependency in here. And then we have our linting and testing dependencies. So I'm not going to assume the GitHub Actions runners come with PS Script Analyzer and Pester. So I've specified the versions I want to install. Then we're going to lint. So we're going to run Script Analyzer. Then we're going to run Pester. And this is the same Pester we just ran when I ran it earlier, where it's going to run our really robust unit tests and our module validation tests. And that's it. That's all validate does. And last is the deploy. And this is going to run when we push to main. Again, we're going to ignore the GitHub directory. And you can see here in the jobs, validation is also going to call that validate workflow, just like our validate. So the one we were just looking at that does the linting and the testing, that's called in 2 different places. And the reason why there's 3 files is because rather than duplicating that entire block of code in the 2 different YAML files, I'm making it reusable. So I only have to update it in one place. Because if I update it, if I didn't have that validate workflow, if we didn't have this, then I would have to make the changes in 2 places. And if that matters to you, then you can do that. I just like to make it reusable. The permissions checks right. You don't need that. That was me copying. That's just I think the PS Swappy module needs that. I can explain that, but you don't need to worry about that. And then our deploy, we're going to rerun it. It needs validation, so validation is going to run first. We're going to check it out. Do a git checkout on the actions runner. We're going to make sure that we're going to look at the manifest version and see what's in the gallery. We're going to make sure we're not trying to push the same version into the gallery. We're going to get the repo name. And this is a step if you don't want to worry about renaming source to the module name, then you don't need to do this. But we're going to get the repo name through the git command. We're going to use that output in the next step to rename it. And you can see how you can take output from one step and use it in another. So we're just going to do a rename item on source. And the new name is going to be the module name, because that's what we need to do when we ship it. And then we're going to publish it. So at the very bottom, whoop, too far. And for the publish, I'm actually using Nate Scherer's publish PowerShell action step. You don't have to do that. You could have it publish module. It depends. I don't know. I don't know Nate. I looked at it. He looked trustworthy. Didn't look like there was any backdoors in there. But if you're doing this at work and you can't pull in public or custom steps, you might need to write like a PowerShell script that does the publish module. And again, this all assumes we're still using PowerShell get. None of this is for PS resource get. Not yet anyways. So that's what our actions are going to do. So I have all these pre-written, and now we're going to copy them we're going to create the GitHub directory. So I'm just showing you they're in the directory above my module currently. So I'm going to do a new item. We're going to call it GitHub workflows. And then we're going to copy our YAML in. Typing's hard, even when you recorded this on OBS weeks ago. So I've copied it in now, and I think I need, there I go. Go me in the past. And now we can see my 3 files in there, which you knew they were there because we just looked at the real module on the side. So I want to add these because remember, GitHub doesn't know these exist yet. We're still all local on my machine. So we're going to say adding GitHub workflows. There we go. We're going to push that up. And now those are up in GitHub. Now if I go up to GitHub, there I go. If I go to actions, we can see those. So we can see the module deployment and validation. And I think visually this is a little bit easier to see. This validation workflow right here, we can't run that directly. That's the one that just exists because the one that's highlighted, PowerShell module deployment, PowerShell module validation, are going to call that. And what we're going to do, we're going to kick off the validation. What would I say? It's a Wednesday, we're bored. We have the workflow dispatch. Let's run it. You can pick what branch. The nice thing about the branch is if you want to do these, if you want to make a Git branch and edit these workflows and just kind of run them one off on the side, you can do that. But we only have main still. So we're going to kick it off. And whoa, neat. There it is. So this is going to run that module dependency checker. It's going to run our script analyzer. And you might have noticed the emojis. You know, when you're looking at the output, I want it to be fun. So I put like a little box there for the dependencies. We're pulling in PS TCP IP because the GitHub TLS cert needs that. That's our script analyzer output and our pester run. And then there's the post checkout code job. But green's good. We got green checks. So our validation passed. Our module is in good shape. So what we want to do now is like, let's make a real change. So I'm back on my local machine. Script analyzer, I know it went by fast, but there's an unused variable in one of the functions, and script analyzer is complaining about it, so we want to fix that. So I'm going to make a branch, and all these Git things, you can do this in VS Code. Again, I'm a terminal junkie, so don't go by me. So I'm going to make a new branch with git checkout B. I give it a good name like my branch. I'm pushing my branch up to GitHub, and in VS Code, I don't know, it might still be publish branch, the equivalent to that. Vim is alias to nvim, so don't worry. But here's one thing. We want to update the version, because once we make this change, we want to push this into gallery. The gallery, in this case, currently has 102, because we manually deployed version 102 before we set all this up. And we can't push 102 up there, because it's already in the gallery. So we're going to update this to 103. I don't know if my PS Swappy module has this, but I do have the code to do it. If you don't want to be in the business of updating these versions manually, it's kind of chewy code, but I have code that'll actually, it'll auto increment that third Semver version, the patch. But if we changed the minor in the middle here from 0 to 1, then it would zero out the patch version. So I call that like the version auto updater. We're not going to get that fancy today. We're still doing it manually, but that is possible. I have done it. So we're going to go into our functions now that we've updated the version. We're going to go into the get sum of numbers, because it has this my unused variable. I don't know if we're going to need this down the road, so I'm going to just comment it out. Save it. We're going to just see, get status. OK, those are the two files I've changed. Let's add them. Let's commit them. We'll push it up to GitHub. Here we go, update 103. Fixed, I think I said fixed variables, fixed issues. Cool, and now we can see, have that. My prompt is a little fancy, so I know I have that one commit needs to go out, so we've pushed that up. And now, GitHub's really cool. I think Azure DevOps does this. I think GitLab does this too. Usually it'll tell you, it'll say, hey, we see this new branch, my branch, and it had recent pushes 19 seconds ago. So we're not going to do anything with that yet, but I wanted to show you my actions workflow for the validate automatically kicked off for my branch because of the way we set the triggers up. So now I know this code is already being run through the ringer of script analyzer and pester, which is great. And we'll go watch it. It's like watching paint dry. That's why we put the emojis in our output. Makes it a little bit more fun. You don't have to watch this, but if past me decides to click on it, it is spinning. Usually while I wait in a demo, that's usually when my laptop decides to crash. Jokes from yesterday. So we can see the output. It's still running. We still have the yellow spinners. Cool, we're good. So it tested my branch with that new code once I pushed it up. And I'm just going to go back a little bit because I did that really quick. So after that, if I go back, once we get the green again, cool. If I go back to code right here, go back to the root of the repo, the code pane, what I'm going to do is, again, it says, hey, my branch had recent pushes a minute ago. I'm going to do a compare and pull request. You don't have to use the GitHub UI. GitHub CLI is actually pretty cool. That's usually what I've done. I'm just doing it through the UI for illustrative purposes, but you can actually even open up a PR with the GitHub CLI, which is really cool. So we're going to open up a pull request. It pulls in the subject, which was just my git commit message. We're going to put nice description in there, commented out unused var. And we can see our checks, but it's going to kick off more checks. So you can see it's kicking off another validate. Now, I want to talk about this because we still even have one more run of the validate. I'm kind of beating the crap out of this thing with validates. At the end of the day, I mean, we've seen this validate only takes a few minutes to run at most, and it's running on GitHub's action runners. Like, it's not my hardware, it's not my stuff. So you don't have to validate it as often as I am in this example. It's up to you. Like, if your process takes, I don't know, if your validation takes an hour, you probably want to pare back how often you're running it. But to me, it's free, so I don't care. We're just going to validate it as much as we want. It's not my containers or whatever. So all the checks have passed. We're good. We're going to merge this. So we're going to merge my branch into main, which is going to kick off the deploy. We'll see that. So I'm going to confirm this merge. It is merged now. And here we go. Look at that. We got a merge pull request, and it's running the validate again. Again, if you want to pair the validates back, that's up to you. But even where I've been, where we had a private GitHub action runner, I still validated a lot because, again, it was our hardware. It didn't really cost anything to do the validate. But you'll see now with this merge pull request, the validate job is connected to deploy because it's going to run that deploy workflow after we do our final validation. And that's what's going to run the steps that send it to the gallery. So we'll wait for this. I'll show you some things, and then there's a couple things I think I glossed over that I just want to show you for clarity after this runs. And time depending, we can get real crazy if we want. We could try to do one on the fly. Yeah?
At which point in this whole process do you sign the script or module?
Sign it?
Yeah.
That's a great question. I've never signed my scripts or modules, if I'm being totally honest with you. I would imagine you would do it in the deploy step because it's probably going to be a one-time thing before you ship it to wherever you want to ship it to, whether it's a gallery or an internal repository. So I would say your signing should go in the deploy workflow. That's my gut feeling. Just thinking about where that type of action would take place. And yeah, I think, because it'd probably be once per version update, you'd want to sign it before pushing it out. So we could take a look at the deploy and see where we would put something like that in it. But we're just looking at the deploy. So the deploy just ran, and it's running, and we're good. So this actually got deployed to the gallery. When I ran this, what you're not seeing, there was actually like a 5 to 10 minute lag time between me running this and it actually showing up in the gallery. So if you're following along at home or you do this and you're saying, oh, my module deployed, like I don't see it yet in the gallery, it takes some time. At least it did the day I did this, so don't be alarmed. And what I did, I can't stress this enough because this burns me all the time. When you go back to your local repo, check out, make sure you're probably still in your feature branch, like we can see I'm on my branch. Check main back out and pull those changes back down from GitHub. Otherwise, you're going to be working in an old version of main. I make that mistake all the time to this day. Now, when we do find module, there it is, version 103 from the gallery. Cool, and then I'm going to show you, if you go to PS Gallery, there it is, version 103, which I think is probably the version up there right now. Cool. So what I wanted to show real quick is when we created that GitHub secret, I realized I missed this. If I go into my deploy, I go to the bottom of this YAML, where it says token, this is where we see that secrets.psgallery. That was the name I gave the API key when I added it as a secret to my repo. Because I explained how when we did the rename, we got the repo name from that extract repo name step, and then we use that in the rename. As far as where the token is used for your API key for gallery, this particular publish PowerShell action, but the one that Nate Scher made, that's where we're wiring that up. And that shouldn't be an output. GitHub is pretty good about not putting secrets in plain text in output. It stars them out, although I know there's still talk about sometimes things get through, so be very careful. But in this case, that's where we wired that up. And I did put that on the repository. I also want to mention that you can, for a whole GitHub org, you can put like an org secret in, which would let you use it for all the repositories in that particular org. I just did it for the one repo. So that's a decision that you would have to make. And I think that's pretty much what we had. we're pretty much close to time. I can stop for questions, or if you want to spend the next 5 minutes trying to push one live, we can do that too.
So are there any sort of like required checks that have to be done to your product to be pushed to PS Gallery?
Yeah, the question was, are there any kind of checks that need to be done to push to the PS Gallery? As far as I know, and that'd probably be a good question for maybe some of the Microsoft folks here. Far as I know, if you have a valid module or a valid script, I don't know if the gallery does any of its own checks when pushing something up. If it does, that may explain why it took a little while for it. When I did this, it took 5 minutes before it showed up. So I don't have a good answer for you. It may be doing something on your side. There's nothing special you need to do. Not that I've encountered so far. Good question.
You have to have GUID in the version.
True. Yeah. Yeah, from the back. You have to have a valid version and a valid GUID. So yeah, some of the things that are just like part and parcel with the PowerShell module. But yeah, that is a good point. Anything else? Yeah. Yeah. Let me see. We're gonna go a little off the beaten path here. Let me see if that Star Wars API module has it. If it doesn't, I can add the code to this. This repo isn't the repo for the content that has like the videos isn't live yet. I haven't made it public, but what I'm doing is I'm just looking at the workflows in a totally different module to see if I have the auto versioner. No, I don't in this case. That's code I can add. I don't have it like anywhere that's live right now, but yeah, effectively what it does is just going to look at it assumes you're using Semver and uses a lot of like system.version and some magic to say like, hey, if say we're at 103 for that test module we were looking at. Oh shoot, we got to reopen that. So if you're at version 103 and you don't change anything in the PSD one, next time it'll just auto make it 104. If I make a change to the major version, I change it from 1 to 2. Whatever the other 2 digits are for minor and patch, it's going to zero those out. So I'll add that code into the repo when I make it public. And I didn't have much else here. I think, kind of went through a lot of this. But yeah, actually, to the point in the question that was asked in the back a few minutes ago is, where would you wire up like a code signing process? That would probably be something you'd want to do in your deployment, in the deployment workflow. So this is really a baseline to get you started. Like the auto versioner I didn't do today. Probably would have added a lot of time to walk through that. But with this baseline, you can start adding whatever steps you want to either your validation or your deployment. And one thing we didn't cover as well is, if you're going to have this publicly accessible and very collaborative, if you want to start accepting pull requests from strangers, I would suggest setting up branch policies in GitHub. That got a little bit more into the GitHub side of it. We didn't do that. You probably saw a warning at one point that said, hey, consider setting up branch policies to protect your main branch. That's good GitHub content, a little outside the scope of what we're doing today, but that'd probably be like a day 2 operation. Yeah.
So with the auto versioning, I'm imagining that you're using probably update module manifest commandment to perform that.
If I remember correctly, yeah. I think I'm doing update module manifest, and then I'm just putting that new updated version in there.
So I've run into this bug sometimes if I'm trying to run, say, my build process in PowerShell 7. If there's a really weird error that says like the PSM1 file is not a valid module manifest, even if I directly point it back to the D file. I don't know if anyone else has run into that. I fixed it by switching back to 5.1, running the exact same thing, and it works fine.
Interesting. Okay, I'll say this. As far as the auto versioning goes, I don't actually, it's been a while since I implemented it. I can pull it up. I don't want to do it live because it's in like some of my like offline private notes. But we can see, because I might also be doing like, I don't know. I don't know if I'm doing update module manifest or if I'm using something else to just update that in the hash table and then just like shipping it out. So hit me up after about the auto versioner if you're interested. But that's all I had. I know we're close to lunch, so I don't want to keep anyone. But any other questions as well? Cool. Well, thank you.